Okay, welcome back to our course on data structures and algorithms. In this lesson, we will continue making new methods to make our list for storing integers more useful. The first method that we're going to start with is the method set. So the set method will take in a couple of different parameters. Let's go ahead and look at what signature we would use. I'm going to continue making these public methods alphabetical. So I'll put it right here. So the set method is going to return a value that is currently at a specific index in the list while it changes it to a new value. So public int set, it's going to take in two integers. The first integer is going to be the index, and the second integer is going to be the value. So our goal in this method is to replace value that's at that specific index with the new value in the parameter and return the original one. So at this time, I'd like you to pause the video and give it a shot. Okay, let's see how you did. First of all, we need to make sure that this index is a good index. So I'm going to check if index is less than 0, we don't have indices that are negative, or if the index is greater than or equal to size. Remember that if we have a list of size 10, the last index is one less than it, 9. So greater than or equal to size would be bad. Well, we're going to throw one of our exceptions again. We're going to throw a new index out of bounds exception. And you can put whatever you think is going to be useful here. You could go ahead and indicate that the index needs to be from 0 to size, but I'll just say it's out of range. Or invalid, you can say it's an invalid index. But the index out of bounds exception makes it pretty clear what's happened. So, all right, we've taken care of that. So if we remember when we throw an exception, that's going to stop the method. So if we get to the line of code after the curly brace in the if statement, we know that we've got a good index. All right, so I'm going to make a temporary variable to hold what is currently in this index in the list. So I'll call this current val, and that's going to be in our array at that specific index. Okay. All right, next what I'm going to do is change what is at that index to the value that we now desire it to be. And lastly, I'm going to return that current value, that original val that was there. So we're not going to change size here because we're simply writing over what was already there. And that should be it. Let's give it a test. Okay, so I'm going to go to my list, create one right quick. Just going to add a couple of values here. 9. Let's try 11. Let's do some odd numbers here. 13 and 15. All right, so we've got several different values already. Let's go ahead and get the value at index 2. You can see that it is a 13. I'm going to inspect the backing array, and you can see that 13 is at index 2 in our array. Let's change that 13 to a 305. So I'm going to go to set. I want index 2, and I want a value of 305. I should get a value returned to me. There's the 13 that we saw earlier. Now if I go and get the value at index 2, I should get the new value of 305. If I go and look at my backing array, We should not see anything change except for the value right there at index 2. Everything else is the same. All right, that looks good to me. Okay, it's time for our next method. So far, we can add to the back of our array right here, but I would like to make it where we can add at any index we want. So let's do that here. Now we could say public void add at index. We could also just say void add and then take in two parameters, int index and then int num or int value. I'll just say value. So that's kind of the traditional way that you'll see lists made, that they'll use the word add for a method name where you just add to the back or front if the list is set up to always add to the front. We're going to specifically just kind of say add, and the fact that it has two parameters with these nice helpful parameter names, index and value, I think it's very clear what this does. So let's go ahead and write that method. Before you do that, let's go ahead and talk about what needs to happen then. So I'm going to draw us a picture. So we've talked a lot about the fact that we have an array that is made, or excuse me, we have a list that is made with an array. So when we want to add at a specific index, let's think about what would have to happen to this backing array. And again, I just like to draw little rectangular boxes. That's how I picture arrays. So let's picture that we had a list with this backing array, and the list contains 3, 1, 7, 2. And our goal is I want you to be able to call add of 5. Our goal is I want you to be able to call that we're adding at index, let's try right in between this 1 and 7. So 0, 1, 2. We're going to put it at index 2. And I want you to try and add a 5. Let's imagine what that's going to look like. Well, in order for that to happen, we're going to have to take everything after starting at index 2 and move it backwards. Okay? So first thing we want to do is we want to check, do we have room? In this situation here, I have room. So I'm just going to move this 2 back. Then I'll come down here and move this back. So I started at the index of size minus 1. We had a size of 4. We started at index 3, and I moved it to index 4. Once I've moved everything back to, and I've come back to this index 2, I'm ready now to put in this new value of 5. Okay, I'm going to keep that in red though. Let's imagine that we're dealing with a full array. And I'll put a 4. Okay, and this time we're going to be adding to index 3. Let's add a 12. Okay, so what would happen in this situation? Well, in this situation, the first thing we're going to look at, after checking our index, of course, is the array needs to have room in order for me to fill it. If it doesn't, we have to expand it. So that's what we're going to do. We're going to call expand. And if you remember, by calling our expand method, we end up just getting a brand new copy of this array, but with more spaces. So let's just imagine that we've already expanded and now we have new spaces in our array. So I'm just going to add a couple more spaces here. And the way we've designed this, they would double in length, but I think that's enough for now. But the key is to understand that we have to call expand. So now we are going to be adding at index 3, so 0, 1, 2, 3, right here. That's where we're going to be adding. So what I'm going to do is I'm going to move everything starting at, this index here is size minus 1, okay? And so we're going to be starting at size minus 1, and we're going to take what's there, and we're going to move it back 1. Then we're going to move forward, and we're going to keep moving forward until we get to here. Once we get there, we'll move it back as well, but we'll stop after that. Now I can insert the new value of 12. Okay, well, that's it. Give it a shot right now. The method is, let's go ahead and take a look at the method signature. Then I want you to pause the video and take care of it from there. Okay, let's see how you did. The first thing we need to do is make sure that the index is a proper index. So if the index is less than 0, or if the index is, careful here, greater than size, then we will throw a new index out of bounds exception, and I'll just say index is out of bounds. Okay, so let's talk a little bit about this. Why am I saying index greater than size? You can see that when we had get, we had greater than or equal to. Well, the reason we're doing that is because you can actually add at an index that is beyond the last index in the list. So, for example, let's say I have 10 items in a list. The last index is index 9. So I want to be able to add from 0 all the way up through 9, but I also should be able to add to index 10. Since once I add a new item, I now have an index 10 available. So adding at the index behind the last current index, that's just like a regular add, but we want to make sure that we allow that. Okay, now that we've checked the index, it's time for us to check to make sure that we don't need to expand our array. So if the size is equal to our backing array's length, that means that we've completely filled it up. If we have 10 spots in our array and our size is 10, they're all filled up. Let's expand. Okay, next, let's move everything to get them in the right place. So if you recall from our pictures and descriptions, we need to start this process at the last index in our list, which is size minus 1. So I'm going to say int x equal to size minus 1. Now, we're going to continue this process, and we're going to move everything. We're going to copy everything from the index set to the index behind it, all the way down, and including the index that the user of this method supplied. So while x is greater than or equal to index. And then I'm going to deprecate x each time. All right, now, array bracket x plus 1 will be assigned what is array bracket x. So the thing in the 10th position will now be copied to the 11th. And for that one moment in time, there's actually going to be a duplicate value there. And this is going to continue all the way down to index. And then the value at the index we're desiring will be a duplicate. It will be duplicated at its current index and the index right behind it, which is fine because we're about to copy over it. So next thing I say is array bracket index, it gets value. And don't forget to increase your size or things will act all kind of weird. Just fixing my formatting here. Okay, well, let's check and make sure it works. Always super important to check each method as soon as you write it. Okay, so what I'm going to do is just make a quick add of the numbers 9, 10, 11, there we go, and 12. So I should have a list, just the numbers 9, 10, 11, and 12. We can go ahead and inspect the backing array. You can see that index 0 through 3 is 9 through 12. I do have a 0 in index 4, but that's outside the index of the list. Doesn't bother me at all. And our users won't see that anyway. Let's try and add at index 2 the number 99. So when we're done with this, our list should have 9, 10, and then 99 before 11 and 12. Let's take a look. All right, well, when we inspect it, you can see we have 9, 10, then 99, then 11, and then 12, just like we expected. Now, let's test again. This time, let's add it 0. I want to make sure I test all the kind of extreme cases. One in the middle, one at the beginning, one at the end. And we're also going to get to make sure that our array expands as it's supposed to. All right, let's add at index 0. So we're adding to the front of our list. And I'm just going to add the number 101. All right, let's inspect. Okay, our size is 6, which is what we expected. Remember, I started with a size of 4, and I've added a couple times. But our array, you see, has expanded to allow more room, and the 101 went right there in the middle. All right, this next thing I want to do is I want to try adding to index 6. Currently, index 6 is not in my array, but I should still be able to add it. Let's add the number 13 there. So to index 6, I'm going to add the number 13. Let's inspect it. Make sure that it happened correctly. It's perfect. I love it. All right. So that's adding at index. Okay, so that's adding at index. The next method I want us to make is index of. Let's take a look how that's going to work. So we can just use this list that we've kind of drawn up. And what if our user asked to find the index of a specific value? Well, we could write methods like last index of, which would start at the back, and we can write a method called index of that starts at the front. I think it's fine to just look at the typical index of. So let's say we say index of 7. Well, as you can see, 0, 1, 2, 3, 4. The expected result here should be the number 4. What we need to do is we need to start right here and simply search through our list until we find it. But how will we know when to stop? Well, we're going to know when to stop when we reach the end of size. And you really want to make sure you use size here, because it could be possible that we had a 7 over here that we actually recently removed and no longer want to say that we have. We don't want to return that index. So if we make it all the way to size and we never find it, then what we want to do is return -1. -1 indicates that it was not there, since -1 is not a proper index of an array. So let's take a look at the signature for this method. We're going to be returning an index, which is an int, and we're going to be taking in a value that we're going to search for. Go ahead and try and write this by yourself right now. Pause the video, give it your best shot, and we'll check back and test it. Okay, let's see how you did. I'm going to simply make a loop. I'm going to start at the index of 0. I'm going to continue while I'm less than the size of my list, not the length of the array. Very important there. Remember, the length of the array is more often than not quite a bit bigger than the size of our list. I'm simply going to ask if the value is equal to the X position in the array, then we found that index. X is the index that we're looking for. So I'll return X. The word return is going to stop this method from continuing. It's going to stop right there and return the index that it found. Well, we have an if. What do we do if it's an else? Well, the truth of the matter is we don't want to do anything. We could leave an else blank. I don't want to do anything. If the value in the X position of the array does not equal the value I'm looking for, don't do anything. Just go on to the next X value. And we don't need the else. Just leave it alone. Okay, so, I tried to compile. I can't do that yet because I promised to return something. And Java's looking at my code and it's saying, hey, what if this never happens? You only return if it happens. Well, then we want to put return -1 right there, outside of the for loop. The number one thing I want you to avoid is what is called an early return. Please do not do something like this. This is so bad. Don't do that. Because that would only check the first number. And if the first number in the list didn't match the value we're looking for, then you return -1. No, you have to wait till you look through everything. It has to be after the for loop. Loop has finished with nothing found. So that's what's so important. Don't return -1 until you search everything. All right, let's test it. All right, I'm going to make a list, but I think actually I'm going to do it here on this interactive. Okay, let's test it out. I'll make a new list, and let's add the numbers 9, 11, 13, and 15. And how about 2 more, 17 and 19. So we got a good long list here. All right, I'm going to look for the index of the number 15, and you'll see it's index 3. We can inspect our list to make sure that that is correct, and it looks good. Let's do another one. Index of 9. And it says index 0. Perfect. Now you remember I didn't put in any even numbers, so let's try the index of 14. You'll see it's -1. Perfect. Okay, so I'm going to say that that's working well. All right, the only thing that's left to do with these methods is we should go ahead and add some Java documentation. I'm going to leave that as an exercise for you to make sure that everything is readable when people want to use their documentation to know how to use our lists. Okay, and that's it for this lesson, and I'll see you next time.